Okay, take your coin. Do not do anything with it yet. Hold your coin.
What's your favorite? Heads or tails?
What you're going to do is you're going to flip your coin 6 times and you're going to count the number of times you get heads.
Okay.
If you count the number of times you get heads out of 6 tosses, what should you get? 3. You should get 3. 3 heads and 3 tails, right? That's what you should get. Because math is never wrong, and that's what the math says, right?
Yeah, but
That's what's going to happen. You're going to get 3 because that's what the math says.
Hey.
Alright, well, so let's flip it then.
So go ahead and flip your coin 6
Hey,
times.
how do you do it?
Count the number of, it doesn't matter. Count the number of heads.
Oh, God. Heads.
That's 2 already.
I'll go ahead every time.
We're going to record this.
Oh no.
I got tails.
You did 6 times?
Don't disturb the evidence.
So I got tails.
We got one head.
Oh.
God, geez.
Why is it so hard to catch? I got heads every time. Oh, you did? 2. I got
About there.
Alright,
I did 2, G. I got 5 heads.
okay.
I got 5.
So we're going to attempt to have you report to me what you got in an organized fashion.
Just start over here.
Okay, so I need you guys to pay attention to the community energy that's going on, and I'm going to be recording your answers, not pointing to who's going next. So I need everybody to answer. You're just telling me the number that you got, and we need this to be quick. We don't want you to wait for 10 seconds before the next
5.
person goes.
5.
2.
You guys are not going in an orderly fashion.
4.
Go ahead.
1.
0.
Oh my gosh.
4.
I got it. Keep going. You're doing great.
5. 4.
3.
4.
Wait, is this 3?
2.
3.
I got 5.
6.
4.
What was that one?
Erase my 1.
3.
Ooh. Hey, flip your coin 6 times real quick and see how many heads you get. Seriously, that's what we did.
Did everybody report?
Or not.
That was really good. I was really impressed with that. Okay, so what did we find out?
What?
Why aren't they all 3s?
You did. Because
The math is wrong.
It's not. It's chance. Like
It's
not always
It's not
going to
math,
happen
it's
that
how
way.
good.
There's variables.
Math is amazing.
Careful. Okay, so what we're going to do is I'm going to now simulate this experience using technology, and we're going to do, so we just did it a total of like 20 times. There are about 20 of you that did the experiment. And we're going to do it about 2,000 times quickly and see what happens. So what do you expect to happen? We had a couple people that were out here on the extremes, right? And we would expect that to happen less often.
Yeah.
We expect this to happen most often. So what shape would this dot plot start to look like if I do this 1,000 times?
Like this.
Do you know what we call that?
A parabola. That looks different. Bell curve.
Have you heard of a bell curve?
Yeah, I've heard of
It
it.
gets, it should like get closer to 50% the more it tosses.
Yeah. So when you did this individually, some of you literally got 0 heads, or you got all 6 heads, and you're like, that doesn't match at all what I thought I was going to get. But when we compile the data of the class, we're starting to get something that looks a little bit more like what we expected. And if we do it 1,000,000 times, we're going to get something even more like what we expected. So let me show you this simulation.
Senor.
Hey, Jeremy.
Okay, so check it out. We're setting the probability of heads at 50%, so it's a fair coin. We're going to toss it 6 times just like you did. So there's the first one, and notice they got 5 heads on the first toss, and so there's 1 dot that goes right there. We're going to now do this, let's do it 20 times, as if we were doing our class. I'm going to take the coins away so it doesn't take as long. So this is like what we got. This is like the results of one class. How many times do you want to do it?
56.
100.
1 million.
If we did our class 100 times, that would be 2,000.
Oh,
Right?
okay.
Yeah,
Just do it
that's why I
2,000.
said 2,000.
Oh gosh.
I can do it again.
That's
Do
bullcrap.
it again.
Okay.
Do it again.
The more we do this, the more it is
Look at how
it's approaching. Look at how close that is. So this is in probability and statistics. This is called the law of. It's called the law of large numbers. If you do an experiment one time, are you likely to get what you expected?
No.
If you do it once.
No.
Well, what if you do it 10 times? Well, you're more likely,
You're-
right?
10 times more likely.
Yeah. So the law of large numbers actually says that when you do an experiment, you should be above 32.
Percent? Like,
No, you should do something more than 32 times.
oh.
If you do it fewer than that, a lot of times it's just considered like, you're not even doing it enough times for that to be valid. So when you hear about statistics being reported in the news, or for example with the election that just happened, you hear about, right before the election, the pollsters were saying this percentage of people are voting for this person. Well, who did they ask? Did they go to like a meeting of the Democrats and they asked them who they were voting for?
Yes.
They might have, and this is where a bunch of other accusations were happening around the election saying, well, the media is skewing all this data because they're only asking these people these questions. They're not asking a representation of, the populace or whatever.
A bunch of dead people voted for Clinton.
Sure. So you need to be careful about how you read statistics in the news because are they really showing you who they're asking, how they're asking the questions? Because if I come up to somebody and I'm like, so you really enjoy Tribe Time, don't you? You're more likely to say yes than if I say, how do you feel about Tribe Time with all that, all those assigned tutorings and all the detentions that you get when you don't go, how do you feel about Tribe Time? You might be more likely to say, I don't really like it so much. So you need to consider when you're looking at statistics, how is the question asked, who is being asked the question, and how many people were even surveyed. Because if you ask, sometimes these commercials drive me crazy. 4 out of 5 dentists recommend. Did you just ask 5 dentists? Like, is that all you did? Because I'm not very impressed with
God,
that.
do you really think of this when you see
Yes, I do. But you should too, because you're buying toothpaste based on a commercial that isn't even statistically
I'm not
significant.
buying it.
Well, your
And
mom.
sometimes I think about like, what
Yeah,
kind
your
of bad
mom.
experience did that one dentist have with this toothpaste?
Right.
You only
wanna
asked
ask
5
him,
people.
like, you want to ask him.
And this one's like,
Him or her.
the toothpaste sucks. Like, what kind of bad experience did you have with that?
So all that being said, please stop flipping coins. All that being said, statistics is a really important subject to study, and so if you go to college at all, you will probably be required to take a statistics course, regardless of what you want to study, because we want to create people in the world who are critical of what advertisers and marketers put out there, and so we want to create this critical lens for you to read those numbers with. So that you can make your own decision about who to vote for, and you don't just like vote for, oh well, everybody's voting for this person because such and such poll said so. Think about what that actually means.